So this is another question from NEET 2018 question paper. Question number is 168. So they have given a redox reaction. Okay, so this is the reaction, and they have asked what will be the correct coefficients for MnO4 minus, C2O4 2 minus, and H plus. Okay, so these are some 4 options written over there. Okay, so for that what we need to do is we need to balance the reaction. They have specifically asked in balanced reaction what will be the coefficients. Okay, so you need to balance the reaction, and what we know from oxidation reduction chapter of say class 12, what we know is there are a number of steps that should be involved to balance a reaction. So we need to look for the mass balance and the charge balance in the reaction. Okay, so by simply following the steps we can easily balance the reaction. So first of all, let's see my main elements. For example, manganese, carbon, they are balanced or not. So if you see here, manganese is balanced, okay, 1 and 1, but carbon here is 2 and carbon here is 1. Okay, so first step is we can balance the carbon. Okay, we can simply balancing carbon. What will be the reaction? If we simply balance the carbon, the reaction will be, so we need to multiply 2 here, right? We need to multiply 2 here, then only this carbon thing will get balanced. Okay, so we will have, let's say, MnO4 minus plus C2O4 2 minus plus H plus, that is giving us Mn plus 2 plus 2CO2 plus H2O. Okay, so I have multiplied this species by 2. So now carbon is also balanced. Now what we need to look is loss and gain of electrons in our species, because this is a redox reaction. So one species might be the losing side on in the terms of electrons, and other species will be on the winning side. So let's look at the oxidation state. If you look at the oxidation state here, you can easily find out the oxidation state for manganese is plus 7, right? Because this is minus 8, but 1 minus is already there, so it should be plus 7. If you look here, 2 4 ja 8, so what we are going to gain is 3, right? 2 4 ja 8 and minus 2, so 6 for 2 carbons, so for 1 carbon it should be plus 3. Here plus 2 is already given, and if you look here, 2 2 ja 4, so it should be like plus 4, right? So that means this species is gaining some electrons, so this is gaining around 5 electrons, right? 5 electron changes there in this particular reaction. Okay, so it was plus 7, now it is going to plus 2. If you look at the other thing, which is C2O4 2 minus, it is actually losing 1 electron. It is losing 1 electron. Okay, but since it is 2, because 2 carbons are involved, so I can say that it is 1 electron into 2. So in total effective loss of electron is 2 here, total effective loss of electron is 5 here. So what we do is we do cross multiplication, right? For example, what we do is, because MnO4 minus is giving you Mn plus 2, okay, so because carbon is losing 2 electrons, so we need to multiply this whole equation by 2. So what we will get is this. Okay, so this step is important to balance the charge. Okay, and in other thing, C2O4 2 minus is there. It is giving you 2 CO2, so I need to multiply this by 5, because this manganese was some 5 electron change. So this is a cross multiplication. The electron change in the case of manganese should be multiplied with the carbon, okay, and vice versa. Okay, so what you do is you will multiply this by 5, right? So it will become 5, and 2 CO2 will now become 10 CO2. Okay, so now my reaction is, so now after doing all this, what is my reaction? After my second step, my reaction is 2 of MnO4 minus plus 5 of C2O4 2 minus, okay, plus H plus, and it is giving you 2 of Mn plus 2 plus 10 of CO2 and plus H2O. Okay, so now this main elements, this manganese and carbon are balanced, my charge is fully balanced. Now what I need to do is I need to balance the oxygen atoms. Okay, so the next step is the balance the oxygen atom, and after that we need to balance hydrogen atom. So if you look at the number of oxygens here, so 2 4 ja 8, so it has 8 plus 5 4 ja 20, so 20. That means total 28 oxygens are there on the left hand side. If you go to the right hand side, we have only 10 to the 20 and 21, right? So we need to overcome this 7 oxygens. So what I will do is I will add another 7 H2O. Okay, so now my oxygens are balanced. The only thing that is left are hydrogens. Okay, so if you can see here, there are also 28 oxygens, here are also 28 oxygens. So in this method, what is done is oxygen is balanced by adding H2O and hydrogen is balanced by adding H plus ion. Okay, so now if you look at the number of hydrogens, we have 7 to the 14, okay, plus 2, 16 hydrogens on right hand side, while we have only 1 hydrogen on left hand side. So what I should do is I should add 15 hydrogens H plus ions on the left hand side too. So now my whole reaction is balanced. Now you can also calculate the charges. The charges should be balanced now. Okay, so 5 to the 10 minus and 12 minus, 4 plus. Okay, so effectively it is 2 minus, right? And it is 10 minus. So 10 minus and 2 minus, it is 12 minus, but 16 plus. So effectively it is 4 plus, right? The charge is 4 plus on the left hand side. If you go to the right hand side, these are neutral. The only thing is 2 to the 4 plus, right? So now my charge is also balanced. You can simply see here. So now my net reaction, my balanced reaction is 2 MnO4 minus plus 5 C2O4 2 minus plus 16 H plus is giving you 2 Mn plus 2 plus 10 CO2 plus 8 H2. Okay, and now you can look for the coefficients. So coefficient for MnO2 minus is 2, coefficient for C2O4 minus 2 minus is 5, coefficient of H plus is 16. So this option is the correct option, right? So you can balance the reaction. In this method of balancing, we have just followed the series of steps. Okay, so the answer number 4 is correct for this question.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.